Right. Having understood the domain and range in very basic terms, now let's understand how to check whether a given curve or an equation is a function or not. So we have the definition. So every time we may not be able to apply the definition. Now that's where we have a test called vertical line test. This vertical line test is preferred when you know the graph of the given curve. Now, how do I determine whether a given curve is a function or not using vertical line test? It's very simple. Again, I'll take one example. We'll take one circle whose center is 0, 0 and radius 2 units. Its axis, y-axis. Now I want to determine, I can even write it as y square equal to 4 minus x square, y equal to plus or minus root of 4 minus x square. Now I want to determine whether this is a function or not. Now to determine whether it is a function or not, again it has connection with the definition. So the definition states that every element has a unique image. So this is the key word, key phrase in the definition of the function. Now to connect this definition to this vertical line test, let's draw one vertical line which is parallel to y-axis. Let's take this one as m1, x equal to 1. Now we need to check whether this vertical line is intersecting the curve at one point or more than one point. Now if you observe, obviously this one intersects the given curve at 2 points. Now what does it indicate? It's very simple. Now it's something like this. If you substitute x equal to 1 here, what will be the y value? If x is 1, obviously y value is plus or minus root of 4 minus 1, root 3. So what does it mean? For one input, we are getting two different outputs. That means one element has two different images. That means this element 1 do not have unique image. So obviously this is not a function. So using vertical line test, we can conclude one thing. If a vertical line drawn parallel to y-axis cuts the graph of the curve at more than one point, then it is not a function. So the statement is, if the vertical line cuts the graph of the curve at more than one point, then it is not a function. So in fact, this statement is implied from this particular phrase in the definition. So definition is very, very important. Every element has a unique image in set P, then only it is a function. And which implies, obviously, if the vertical line cuts the graph at more than one point, it means that a particular element has more than one image. That means, in this case, this element 1 has no unique image. That means, if you substitute x equal to 1 as we saw already, you will get two different elements, which is root 3 and minus root 3. So more precisely, you can understand it like this. One element. So this is like domain. This is like codomain. X-axis always refers to domain input. Obviously, y-axis will be your codomain or range. Now the element 1 has two different images. So it does not have unique image. So it is not a function. So this is the definition of a function. Now let's derive one very, very important formula. How do we determine number of functions from given set A to another given set B? So to derive this one, we will take the help of fundamental principle of counting and permutations and combinations, which is very simple. Now let's assume in the given set A, there are n elements and the given set B has r distinct elements. Now I want to determine how many functions f from set A to set B can be defined, total number of functions. Now again, everything has its connection to the definition. Let's assume the set A has some n elements like this, and set B has some r elements like this. Now we need to determine how many different functions are possible. Now again we'll take the help of definition. I said every element in set A has unique image in set B. So can I say it like this? In how many ways? In how many ways I can allot a number from set B to the elements in set A? Or in how many ways I can assign the images to elements, every element in set A, and it should be unique. That means if x1 is assigned to one of the values in B, x1 cannot be assigned to any other element in B. That is the meaning, right? Now here, let's start with element x1. Now element x1 has obviously r choices. So any one element from this r different elements can be the image of x1. So definitely x1 has r possibilities. And using fundamental principle of counting, again if I take x2, let's assume x1 is assigned to 2. So the image of x1 is 2. Now as I said, now we should come to x2. Now x1 job is done. Now x2, again for x2 also we have r choices, because we said every element must have unique image. That means again 2 can be the image of x2. Because two or more than 2 different elements can have same image, but one element in set A cannot have 2 different images. So again x2 has r elements possible, and if you continue like that, even x3 has r images up to xn will also have r possibilities. So if you multiply r how many times? N times, the answer will be r power n. So the formula is n of b whole power n of a. So this is the basic formula to determine the number of functions that can be defined from set A to set B. Now to understand this one very clearly, of course in the exam we don't get problems which are like direct application of this one, especially in JEE. Now let's take one example which has some exception in it. If I want to determine the number of functions that can be defined from set A equal to 1, 2, 3 to the set B equal to some 4, 5, 6 or else 1, 2, 3, 4, 5. But there is a twist here such that f of I is less than or equal to f of j for all I less than j. So this is the important point in this question. Now observe carefully. If this part is not there, this question would have been very easy. The answer is directly 5 over 3, because number of elements in A is 3, number of elements in B is 5. So answer will be 5 over 3. But he is not asking the total number of functions directly. He is asking us to determine the number of functions which satisfies this property. Now we need to understand this property very clearly. Now let's use the arrow diagram to understand this one very clearly. Set A has 3 elements 1, 2, 3. Set B has 5 elements 1, 2, 3, 4, 5. Now let's assume f is the function. Now the meaning of this one, f of I less than or equal to f of j for all I less than j. So the meaning of this one is, of course, I and j belongs to A comma B, needless to mention, because f of I and f of j will be in set B, I and j will be from set A. So what is the meaning of f of I? This is the image of element I. So I and j are in input domain. F of I and f of j should be taken from set B. Now observe carefully. When I say f of I less than or equal to f of j for all I less than j, if I write something like this, f of 1 less than f of 2, Yeah, this is correct. Because if this is I, this is J. If you take this one, definitely even these two must satisfy this relation. Because 1 is less than 2. But if I take f of 2 less than f of 1, for all, according to this condition, this one must be less than this one. But in this case, I is greater than J, so we can't take this one. So, I hope this is clear. Now, using this condition, now we need to determine how many such functions are possible which satisfies this one, f of I less than or equal to f of j for all I less than j. Now we cannot count it manually. So here we need to consider the cases. The reason being, there might be the cases where f of 1 less than f of 2 less than f of 3. This is one case. Because as I said, both I and j belong to set A because they are inputs. So if I take this one, we need to verify whether this condition is satisfied in the first part of the inequality as well as the second part of the inequality. If you observe carefully, f of 1 less than f of 2 less than f of 3, at the same time 1 is less than 2 and 2 is less than 3, and obviously 1 is also less than 3. So certainly this one satisfies this condition. Now we need to determine how many functions are possible which satisfies this inequality. Now if you observe carefully, what is the definition? Every element in set A has unique image. So in this problem, we need to select the images for 1, 2 and 3 from the set B. And set B has how many elements? There are 5 elements in set B. Now, if you take this one as the case, f of 1 less than f of 2 less than f of 3. Now the images for 1, 2, 3 are in ascending order. So here arrangement is fixed. What do I mean by that? Let's take f of 1 less than f of 2 less than f of 3. So what do I mean by that? F of 1 is not equal to f of 2, obviously it is not equal to f of 3. So the images of 1, 2, 3 are different. So that means from these 5 elements, I need to select 3 elements. Is it correct? From these 5 elements, I need to select 3 elements. The reason being, I need 3 different images for these 3 elements according to this condition. And into only one possibility, we should not write 3 factorial because this arrangement is fixed. So my job is just to select. Now I will show you one such combination here. 1, 2, 3, 1, 2, 3, 4, 5. So I will do like this: 1, 2, 2, 4, 3, 5. Because f of 1 is less than f of 2, which is less than f of 3. I will just select these 3 elements, and there is no arrangement. Because after selecting 3 elements, the least one must be assigned to f of 1, and the next least must be assigned to, and the next one will be f of 2, and the greatest one will be assigned to f of 3. So arrangement is fixed here. And case number 2. So in this case you will get only 5C3, and which is 10. Case 2. F of 1 less than f of 2, which is equal to f of 3. Because we have equal to also here. That means f of 1 less than f of 2, and it is satisfying this one. Even I can take f of 2 equal to f of 3, f of I equal to f of j for all I less than j, f of y equal to f of j for all I less than j. So in this case, one can observe f of 2 and f of 3 has same images, and f of 1 will be different from this one. So essentially here I need to select only 2 images because f of 2 and f of 3 are having same images. So out of these 5 elements in set B, I will select only 2 elements, which is like 5C2, and again there is no arrangement because again the arrangement is fixed. Now if you want, I will show you one simple combination here. 1, 2, 3. 1, 2, 3, 4, 5. Now I will select 2 elements. Let's assume I have selected element 2 and element 4. So according to this arrangement, certainly I need to assign element 2 to 1 because f of 1 will be having least 1, and elements 2 and 3 will have 4. So that is the meaning of 5C2 because I need to select only 2 elements. Again 5C2 is equal to 10. Now again in case 3, f of 1 equal to f of 2, which is less than f of 3 when this is possible. Now here we are equating f of 1 and f of 2, and this is less than f of 3. So again here, for these two elements 1 and 2, the image is same, and the image of f of 3 is different from this one. So again I will be selecting two images, and again this is 10. And finally, I think you will get one more case, which is all are equal, f of 1 equal to f of 2 equal to f of 3. So if you take these four cases, then it will completely consider all the given possibilities which satisfies this one. So all these four cases will definitely satisfy this inequality, the given condition. So again here, all three elements have the same image. That means out of 5 elements, I need to select only one element, and which is equal to 5. Therefore, what is the answer? 10 plus 10 plus 10 plus 5, 35. So this is how we can determine the number of functions. See, this formula is okay, but if the question is directly only from number of functions different from set A to set B, this is very simple direct formula. But without understanding the logic behind this one, it's very difficult to determine the answer, especially when you are given with this type of exceptions. So once again, f of I less than or equal to f of j for all I less than j. So we need to select the elements in B. That means we need to select the images for the elements in A in such a way that they satisfy this inequality. And that's why we have got 4 different cases. One is all are different. The second and third case, 2 are different and 1 is different. 2 are equal and 1 is different. And fourth case, all are equal because we have equal to symbol also. So this is how we can determine the answer.